Okay. And these probably are going to be a different order from what you would see when you're going through the test on these. So this is just random questions in any particular order. So you'll probably see something different when you actually take the Chapter 8 test. But here's the questions as we're going through these. So okay, so number one, we got probability of A is 1/7. Probability of B is 1/9. And we're going to find two things. We're going to first find the probability of A intersect B. Okay, now the one thing I forgot to put back up here is that when we do A and B, those are independent events. Okay, so with those being independent events, when you find A intersect B, all you're going to do is just multiply those two things together. So it's just 1/7 times 1/9. So it's 1 out of 63. Okay, so as long as they're independent, just multiply the two things together, and that's all that you have to do. Okay, second one is they're going to ask you to find probability of A union B. And to me, they talk about some different things. To me, this is one just to use the formula. That when you're doing the formula for A union B, that's the probability of A plus the probability of B minus what we just found here, which was the intersection of A and B. Okay, and then just plug in your numbers. So it's 1/7 plus 1/9 minus 1/63. Because you're multiplying these together, they're all going to be 63 for your common denominator. This one we're going to multiply by 9. This you multiply by 7. So that's 16 minus 1. That is 15 out of 63. And it's going to tell us to put the answer in simplest form. So in this case, divide both of those by 3, and that should make it 5 out of 21. Okay, and again, as long as they're independent events, that's your two formulas that you're set up that you're going through those. All right, question number 2. Ask you to use a Venn diagram, and you really don't even have to use a Venn diagram on this one, but it tells you that the number of A is 9, the number of B is 14, and A intersect B is 6. And what's the number of A union B? All right, and again, it tells you to do a Venn diagram, and you can do a Venn diagram on this one if you want to. But to me, this is where, again, we're just going to use the formula that we had right here for the B part here, that it's A plus B minus the intersection. So same thing, it's A plus B. Oops, sorry. Write it down here, minus the intersection. No, that's 9 plus 14 minus 6. 23 minus 6 is 17. So they tell you to use a Venn diagram. Honestly, on this one, if it's that simple, you don't need a Venn diagram. I mean, if you want to, that's fine. Nothing wrong with doing that. But to me, this is just a lot quicker just to add and subtract the numbers together. You're free to do, if you're a Venn diagram person, then, go draw circles all you want. Make yourself happy. Okay, number 3. Number 3 says it's a single 4-sided die. Find the probability of getting a number that is less than 2. Well, there's only, if it's a 4-sided die, there's only one number that's less than 2. So that's going to be 1 out of 4. Okay, and again, just a sample question. It may be that it could be, finding a number that's less than 3 or greater than or equal to 4, but they'll give you some number and you'll just have to go through it. Okay, number 4. This is one where they do give you a Venn diagram. Again, it's another one of those where I don't think you need the Venn diagram, but just to show you what the problem is, they tell you that the number of A intersect B is equal to 6. The number of A union B is equal to 32. And the number of A is 16. And it says basically find the number of B. Okay, and they give you a Venn diagram. There's your A and your B. You can go back and plug in the numbers and go through everything. But to me, this is another one where you don't really need the Venn diagram. They've pretty much given you everything you need there. You can go back to the same formula that we had back here. If it's A union B, well, it's A plus B minus the intersection. We've got everything here. So if we go A union B, that's the number of A plus the number of B minus the number of the intersection. So that's 32 equals 16 plus B minus 6. So over here we'll do 16 minus 6 to make that 10. Subtract the 10 from both sides, and then we get that B would equal 22. All right, and again, you can use the Venn diagram, but to me, it's easier just to go back to that formula and use it just a little bit quicker way. If you want to use the Venn diagram, then definitely go ahead. All right, number 5 goes to the cards problem. So we've got 2 cards can be drawn without replacement. So we're going to find the probability of the second card is not a heart. Given that the first is a heart. Okay. So we're drawing 2 cards. We're taking the first card and throwing it away, which automatically means now we're down to 51 cards. Finding the probability that the second card is not a heart, given the first card is a heart. So it's asking us to find the probability of it not being a heart. So if we start with the hearts, we've got 13 that are hearts, which means there's 39 that are not hearts. So we took the first card out, says, given that the first card is a heart, so we're taking this off the deck. Now we're down to 12 hearts and 39 that's not hearts. It says find the probability of the second card being not a heart. Well, that's just going to be the 39 out of 51. Now, in that case, it will simplify. You can divide both of these numbers by 3 to make that 13 over 17. Okay, problem 6. And we did this exact same. I remember going through this one in the homework, forgetting now what section it was in. It's another one where they give you a Venn diagram that basically it says something like this, that there are 19 movies that are PG-13 that made more than $100 million. There were 31 PG-13 movies that made less than $100 million. There were 37 that were not PG-13 that made less than 100 million. And then they said, find out how many movies were not PG-13 that made more than $100 million. Given that there were 100 movies total that were being compared. So this is one of those, there's no overlap on those. It's either PG-13 and greater than 100 million or PG-13 and less than 100 million. So there's absolutely no overlaps with these. So basically we're just adding up all these numbers to make it out to be 100. Well, that's 50 plus 87. So 87 plus what equals 100? Well, there you go. It's 13 movies. Okay. And again, they tell you use the Venn diagram to answer the questions. You don't really need the Venn diagram because you would just wind up having 4 bubbles that don't overlap at all to find out what the number is going to be. Okay. So when you see that question, just realize it's not as much as they say it's a Venn diagram question, it is not a Venn diagram question when it comes down to that. Okay, number 7. This one tells you to insert an intersection or a union. To make the statement true. And basically gives you something like this. Okay, so you've got a set of numbers here. You've got the empty set equals, and then it's the exact same set of numbers there. Basically, this is like adding nothing to it. So if you start with the original problem and you add nothing to it, it's not the intersection, because there would be no intersection here. The intersection would just be the empty set. So since you started with one set and got the original set back, in that case, that would wind up being the union for that problem. If you take the original, add nothing to it, you get the original back. Okay, and honestly, for this problem, when I looked at it, going through the samples on these, the hardest thing for me was reading this one because it was all crammed together. And I had to go back. When I first read it, it didn't make a lot of sense because it was like, it was so crammed together. I almost had to go back and rewrite it where I had basically spaced it out a little bit. So I had like 2, 13, 8, 6, space, empty set. And then I put the equal way over here and had it like that. Because when the way, and this doesn't even show it, when I was reading it online, looking at it, it was so crammed together, it didn't really make sense. So I almost had to go back and space it out like this, because when I first read the problem, it didn't make any sense to me. So for this one, when you see one like this, kind of put this over here and put the equal way over here so that you can see, all right, what do I need to do with these two sets to make it look like this part? And as long as you're working with the empty set, it's pretty much one of two options. If you get the original set back, it's union. If you get the empty set back, then it would be the intersection. All right, number 8, pretty similar to it. It's A, G, J, and K equal to J, K, G, and A. And basically, is that true or false? Again, order doesn't matter. If you got the same 4 elements here, the same 4 elements here, doesn't matter the order in that case, then that one would be true. Okay, number 9. This one is a pair of dice is rolled. It says, what is the probability of the sum equal to 6? All right, and if you have, I don't think I have it here in front of me. Back when we did this, back in section 3, I think it was, one of the sections we went through and talked about rolling 2 dice, that you have to look at all the possibilities for this one. That it's a 1, the ways you can get 6 is it's a 1 and a 5. It could be a 2 and a 4, or it could be a 3 and a 3. You also have to look at the flip side, that it could also be 4, 2, and then 5, 1. So your total possibilities out of this one would be 5. And if you went through and checked every single possibility, you know, with 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, you would do that for every single dice. So there's 36 possibilities, different unique combinations of numbers you can get for those. So that one would be 5 out of 36. So anytime you're doing the 2 dice rolled and you're looking for some numbers, that, remember, it's always going to be 36 possible outcomes depending on what you get first and what you get second when you do those. Okay, number 10. Back to, in this case, just 1 die. So we're 6-sided die, so we're just 1 out of 6 possibility on this one for each side. They change gears on this one just a little bit. This one says find the favor, or the odds in favor of getting a 3. Okay, so when you're doing the odds, that's where I think all the answers should be, like in the colon. This is how many ways you can get a 3 versus how many ways you cannot get a 3. Well, if there's 6 sides, there's only one way you can get a 3 is by rolling a 3. That means the other numbers would be not a 3. So in that case, it would just be a 1 out of 5. And I don't remember. I think they're going to have it this way. They might use the word 2. It could also be a fraction, but I think it's going to be one of these two. I think it's going to be the one with the colon. But that's one. Just make sure you don't fly through it too fast, because you got to make sure that when it talks about odds in favor or odds against, that's where you got to go back and do successful versus not successful instead of total for these. Okay, 11. This is one where it tells you that's all counting numbers not greater than 5 equal to 1, 2, 3, 4, 5. I'm just going to ask you true or false. Okay, and if you don't know, the only difference between counting numbers and if they talked about whole numbers or integers, whole numbers you start at 0, counting numbers you start at 1. I mean, that's the difference of the two. Integers is anything positive or negative, and I don't think they will throw integers at you in this case. So it's counting numbers, basically you start at 1. If it was whole numbers, you would start at 0, and that's the only difference of the two. Okay, so it says all counting numbers not greater than 5. Well, if it's not greater than 5, that means that it's less than or equal to 5. And that's 5, 4, 3, 2, 1. So in that case, that statement would be true. Okay, and for 12, this is where they go back and give you just one, to me, easy little problem. Being trustworthy and being employed. They ask you, is this disjoint? And just remember that disjoint means that there's no overlap. So it's possible that you could be trustworthy and be employed. Hopefully that would be the case for most people. So they ask you, are those two things disjoint? Well, no, they're not. Because there's hopefully an employee or two out there that's trustworthy, that's also employed. Hopefully all the trustworthy people are not unemployed. All right, 13. Okay, and this is one, again, I remember doing this one of the homework sections we had. Maybe different numbers. I'm just going with the sample problem that we had here. It tells you that this was a real estate company receiving applications for people for a job. There were 72 people with experience. There were 47 people with a degree. There were 27 people with a license. There were 28 people with experience and a degree. There were 16 people with experience and a license. 14 people with a degree and a license. 10 people with all three with a degree and a license and experience. And there was 23 that had basically nothing. No degrees, no license, no experience, no anything on those. Okay, and based on the numbers, what we had from those was that from there you could draw your Venn diagram. And you had to have 3 circles. And you always start with what they had with all 3 in common. So starting in the middle with all 3 parts, that was 10. So that would go right in the middle here. Okay, got to mark where we're putting everything, right? So let's put experience was first, so that will go here. Degree was second, that will go there. And then the license was third, so that'll go there. All right, and the 23 people didn't have anything. That goes in the corner, just somewhere, just outside the circles. You can put that one anywhere. It doesn't really matter where you put it. Okay, and then from there, it's just cutting back to the different parts that you have. It says there's 14 people that have a degree and a license. So take out the experience. There's 14 people in the overlap that's here between degree and license. Well, if we already got 10 in common here, we're just going to do 14 minus 10 to make this 4. So there's our 14 people that had a degree and a license. We need to have 16 with experience and a license. So the overlap between experience and a license would be here. There were 16 people, so we'll do 16 minus 10 to make that 6. And then at the top, between the overlap of those 2 circles, experience and degree, there were 28 people. Well, if there was 10 that was already here, we'll do 28 minus 10 to make that out to be 18. Okay, and then we're going to use those circles with the numbers inside each of those little sections to go back and get the other numbers that we had back up here. So with the license, there were 27 people total. And if you look inside the circle, there were 10 here and another 10 here. So that was a total of 20. So it means there's 7 people that were outside of the intersections that we had here. I'm sorry, I couldn't see that. Okay, make this so you can see this one this time. All right, for the degree, the next one up, there was 47 people that had a degree. So that's everything inside of this circle back here. 47 was the total. We're going to take out the 18, the 10, and the 4. So that's 22. That's 32 people that had some combination of one of the other things. So there's 15 people that had just the degree. All right, and then for experience, same thing. There were 72 people total. So take out all the people that were here. So we're looking at just these people that had experience. Again, not worrying about these. Just these people had experience. So that's 28 and 6. That is 34 people. So with the 34 people, we'll subtract that from the 72. So then there were 38 people that had just experience. And then once you've got those filled in, then the questions are going to ask you to do something based on that chart. Okay, so the questions were, just said how many applicants total? Okay, and that's where you can go back and add in each individual number that's here. The way I kind of looked at it was, okay, if we know there's 72 people that had experience here, take out that experience block that was here, then you can add in the other numbers that were here. So then it's 72 plus, we've got 23 plus 7, so that's 30, plus another 19 that would be here. Add all that together, it should come out to be 121. That's 11, 10, 11, 12. Yeah. All right, for B. B asked, how many applicants did not have sales experience? Okay, to me, easiest thing to do is just take that circle that we had here, there's experience, and just cover it up. And the only thing then would be just to take all these other numbers that you have and add those together. So it's 23 plus 7, which is 30, plus another 19 that's there. So that's 49 people. Okay, put C down here. C was how many people had sales experience and a degree, but not a real estate license. So how many people had experience plus a degree? But not a license. Well, that one, to me, that's one that the questions, that was basically, they gave it back up here. Because if you go back to see what had experience and degree, well, they told us there were 28 people that had an experience and a degree. So that one, you just have to read what they were given in that case. So don't know if they didn't realize that in the question, but anyway, that's what they asked for. Oh, wait, I'm sorry. That was one that had all three. My bad. Sorry, I was reading, wasn't paying attention here. So for that one, they don't want the people that had all three in this case. So the people only had the experience and the degree. In that case, that would be 18. My bad, I was saying that wrong. Okay, so we've got, this is the people that had all three. Again, people only had the experience and the degree. That was 18 that was there. My bad. See, that one you do have to go back and read through the Venn diagram. Because what we were given back here with experience and degree, that was experience and degree, and also had a license mixed in with that one also. So we had to take out that triplicate part of it. All right, and then the D part, how many people had, see if I put D over here, keep it all on the same paper. For D, this was how many people had only a real estate license. And again, that's going back to our Venn diagram here. These were people that had a license with something else. The only people that had just a license, there were 7. Okay, so all these questions that we had here, basically you got to go back and just pick through the numbers that's in the Venn diagram. And sorry about that one little mistake there. Okay, so 13, definitely a long one. And again, just to get through the setup for that one takes a little bit of time. Okay, just realized if I turn the paper sideways, it will all fit on here without having any glare on the sides. So maybe that'll make it a little bit easier on y'all. Okay, so for 14, another one of those where they give you another Venn diagram. So we got P of Z is equal to 0.46. P of Y is 0.39. P of Z intersect Y is 0.17. And it says use a Venn diagram to, and then they give us all these questions we got to answer, and then we'll go from there. Okay. So this is one of those problems that, to me, you can do it without a Venn diagram, but it does make it easier to have a Venn diagram on this one. All right, we have Z and Y. The intersection of those two numbers is 0.17. To get the other numbers in, we're just going to subtract. So we've got 0.46 minus the 0.17 for Z. That should give us 0.29, subtracting those numbers. And we'll do the same thing for Y. We'll do 0.39 minus 0.17, and that will give us 0.22. Okay. So here we go. So here's how the questions are going to ask you. For part A, it's going to ask you to find probability of Z prime intersect Y prime. Okay, now the one thing they don't give you on this question before we start to answer everything is we've got all this information that's here. You've got to know that there's still, because this total doesn't add up to be 1 for this one. We've got to figure out what's outside of Z and Y. We've got the intersection, we've got Z, we've got Y. We've got to figure out what's outside of this circle. So if we've got everything of Z and Y that's here, if you add those numbers together, that is what, 16, that's 18, that's 1 there. That is 0.68. So that's everything that's inside of these two circles. To get what's on the outside of it, we need to do 1 minus that 0.68, which would be 0.32. So that 0.32 is going to go outside of those two circles. Okay, so that's the one thing that you're not given that you do need to go back and answer all the questions that's here. Okay, now, and this is one where you almost have to kind of break it apart in little pieces, because you could use a formula for this one, but we don't really have the pieces, because we could go back and figure out what's, not in Z, figure out what's not in Y, and find all those different pieces for this thing. And you can do it that way. If we kind of stick with what they have here, Z prime, again, well, this is where we'll start just covering up parts and pieces of it, that if we're talking about Z prime, that's everything that's not in Z. So that's 0.22 plus 0.32. And if you want to do the intersection, if you just write down the two different parts of here, if we take Z prime, which is everything that's here, if we take Y prime, which is everything that's here, the intersection is going to be just what they have in common. So that would be everything that's here. So then the intersection would be 0.32. All right, second thing they're going to ask for is the intersection of, the union of Z prime and Y prime. Now, in that case, to me, that one would be one that's an easy formula to use, because with Z prime union Y prime, we've got the second part that's here, that this just needs to be Z prime plus Y prime minus what we had for the intersection right here, which was Z prime intersect Y prime. Well, and back up here, if Z is 0.46, then Z prime would be 0.54, just subtracting that from 1. Y prime would be, subtract that from 1, that would be 0.61. Okay, so from there, we can just use a formula. We can do 0.54 plus 0.61 minus the number that we had here, which was the 0.32. Put all that together to get 0.83. Okay, so if you want to, when you go through and do those, you can do, again, they kind of do the intersection part back here, which we could do. And to me, that one's probably a little bit easier, so you can just kind of see it. But anytime you're doing the union, if they just gave you the intersection, then to me, you can go back and do the formula to go through on that one. Okay, for C, let's do Z prime union Y. Okay, and since we're doing union, basically it's the same thing. We're going to do Z prime plus Y minus the intersection of Z prime and Y. Okay, the only thing we'll have to find is actually this part of it, because Z prime, we just said a minute ago, that was here, that was 0.54. For Y, that is 0.39, and we've got to find the intersection of Z prime and Y prime. So over on the side, if we think about what Z prime is, that's 0.22 and 0.33. And then the intersection with Y, well, Y is 0.17 and 0.12, sorry, 0.22. So the one thing they have in common there is the 0.22. So then that's the part that we have to take out. All right, and doing that part, adding everything together, that should come out to be 0.71. All right, and then the last thing that asked for here was the intersection of Z and Y prime. Okay, and if we're doing intersection, you almost have to go back and just write out what the pieces are. So for Z, back up here, that was 0.29 and 0.17. And we're going to find out what that has in common with Y prime. And for Y prime, that is everything outside of Y, so that's 0.29 and 0.32. So what they have in common then would be the 0.29. Okay, so there's your two big questions on the test. You've got the Venn diagram with the three parts of it. You've got the other Venn diagram here where they give you two probabilities and the intersection of the probability of those two things, and then you just got to basically run the math and do the numbers to find all the parts and pieces of it. And some of them, and again, you could even go back to this one if you want to use the Venn diagram to get there. But anytime I see the unions, I'm already thinking about using the formulas on those. You know, you can do it without it, but I kind of like formulas because to me it just seems to flow a little bit easier. All right, for 15. This one, it goes through, it's a big, long, drawn out process of it. But basically, it's this there are 6 people. There's Karina, there's Kyle, Lorraine, Jacqueline, Taylor, and Naisha. Okay, and it says, it gives some different things here. Basically, these are 6 people that are college students. They all live in the dorm in a suite together. They have to go pick up pizza. It says nobody wants to go, so they put names in a hat and they draw the names out of the hat. And it says for part A, it says what's the probability, or what's the sample space? Lost my words there for a minute. What's the sample space for Taylor being selected? And again, it says it's a random experiment, all everything that's going on here. And they basically do abbreviations on this one to kind of keep it short. So if you're doing the sample space for Taylor, Taylor can go with everybody. So it's Taylor and Karina, Taylor and Kyle, Taylor and Lorraine, Taylor and Jacqueline, and then Taylor can go by herself, Taylor and Naisha. So you just got to have a T. And they mix up the order a little bit. The T doesn't always have to be first. But you just need 5, since there's 5 other people that she's going to go with, you need the T along with the 5 other names that you have there. Okay. And then the B part, 2 names selected have the same number of letters. So with that one, you're going to have to go back through with all the names of the people here and write out how many numbers they have there, or how many letters they have in their name. So Karina has 6, Kyle has 4, Lorraine has 2, 4, 6, 7. So far nobody has the same amount. 2, 4, 6 for Jacqueline. Taylor has 5, and Naisha would have 6. Okay, so there's only 3 people that have the same amount of letters. So we've got to have Karina and Jacqueline. You could have Karina and Naisha, or you could have Jacqueline and Naisha. And I think for those problems, sorry, slide that back down. It's just a multiple choice option on these. They'll give you some that's there. Biggest thing on this one is where you have the 5 here. Just make sure that there's not any repeats, because sometimes they'll be sneaky and write the same thing twice. And just because of the way it's written, it's hard to see it just because of how it's written when you go through those. So just make sure you've got all different combinations there and that there's not any that repeat. All right, for 16, go for a little shorter on this one. This one you're given different sets of numbers. X is ABC, 19, 20, and 21. Y is B, D, F, 19, 21, 23. And then Z is BD, 20, 21, and 23. Okay, and it says list the members of the given set using set braces, and they only ask for one thing here. It's X union with the intersection of, actually, y and z. Okay, so first thing you want to do is find the intersection of y and z. Now that's everything here. So the intersection of y and z is everything they have in common. So that's going to be a b and a d, 21 and 23. And we're going to union that together with everything that was in x. So that was a, b, c, 19, 20, 21. So putting those two things, and again, you do not have to, I think this is one of the questions we had when going through the homework with these. You do not have to rewrite something twice. So once you write it once, you don't have to put it twice when it comes off of these. So we've got A and B. You can have B here, but we don't have to write it twice. Just once is fine. We also had C and D. For numbers, we had 19, 20, 21, and then 23. Next two questions are both really short, really easy. 17 says a teacher has found that the probability the student studies for a test is 0.6. The probability the student gets a good grade is 0.5. And it says the probability that both occur is 0.33. It says, are these events independent? Okay, and you got to just kind of step back for a minute and just look at the numbers because, I mean, we know that if you study, you should make a better grade in most cases. There's always exceptions to the rules, but here's the math on this one. If you go back to the part where we're doing the independent events, basically it says if these two events are independent, then if you multiplying these two things together would be the answer that we get for this part. So if they're truly independent, if you do 0.6 times 0.5, then it should be 0.3. We got that it was 0.33. So they asked, are these two things independent? Basically, are these two things equal? Well, no, they're not. So if they're not equal, then they're not independent. And that's basically what it comes down to. So if it really was independent, you would do 0.6 times 0.5 and it should have been 0.3. We got something else different. So they're not independent. They're dependent on each other. There's a little bit of interaction between those two things. Okay, and then 18, I think this was one similar to one of the first questions that we did. Basically, it gives you two different things and asks you, are these two events disjoint? Being ambitious, yeah, we did. Trustworthy and employed, I think is what it was. Being ambitious and being unemployed. So, I mean, obviously, again, you can be ambitious and be unemployed. So they ask, are these two things disjoint? No, they're not. They are not totally separate. Okay, for question 19, basically says this, that there are 14 relatives invited to a party. She's got her mom, four aunts or aunts, depending on how you say that one. Sorry, here we go. 14 relatives. We've got one mom, four aunts, two uncles, three brothers, one cousin who's a male, and three cousins that are female. And they just asked for some simple probabilities on this one. Very first question says, very first question is find the probability of it being that the first person who shows up is a brother or an uncle being first. Well, in that case, we know it's going to be out of 14 because that's how many people are showing up. There is three brothers and two uncles, so that's 5 out of 14. 5 out of 14 won't simplify, so that's it, just 5 out of 14. Okay, for B, probability of a brother or a cousin. It didn't say male or female, so then any of them would be fine in that case. So we've got three brothers, we've got four cousins total, so that's 7 out of 14. That'll simplify down to a half. And then for C, we're looking for the probability of being the brother or the mother who shows up first. So three brothers, the one mom, so that's 4 out of 14. So that would simplify down to 2 sevens. Okay, and those are all just simple probabilities. There's nothing too complicated that you have to do those, just adding the different parts and pieces of it. Okay, and then the last question is you have a 12-sided die, just one. Equal probability of getting numbers 1 through 12. And it asks for the probability of getting a 12 or a 10. Well, if it's equally, it's fair, it's not loaded dice of any kind. In that case, that's going to be 2 out of the 12 numbers. So it's 2 out of 12, just simplify to make it 1 out of 6. Okay, and there are the 12.
Connected to 9 a.m. meeting 2 and TH, everyone. 1.
Right, sorry about that. I was trying to hit the record button I had back up here.